Alright, now that you have your air filter assembled, it's time to repair some of the electronic components you're going to need in the event of a power outage. I've listed here the components you're going to need, and I'll cover each briefly. There should be some links in the description where we sourced our materials from, but if those are unavailable, I'll cover some of the common places you can find these elsewhere. First off, you're going to need a 55 amp hour deep cycle AGM lead acid battery. Now that's a bit of a mouthful. 55 amp hour lead acid battery will probably just about do it. You're only going to need one of these. You can find them probably somewhere on Amazon or at hardware stores or auto parts stores if ours in the description doesn't work. You're going to want some ring terminals to hook up your wire to your battery. You're going to need two of these, one for each end. You can find these in an auto parts store. If your battery that you get is different from ours and that it doesn't have something that'll connect a ring terminal to, just see what your battery needs and get terminals for that. You're going to want some 14 gauge wire, about 10 feet of that. A little bit more doesn't hurt, so you have a little bit extra to work with, and you can find that somewhere like a hardware store, maybe some auto parts stores will carry it. You're also going to want a butt connector. There's going to be a bit of wire connecting here that we're going to need to do. We only used one. You may want to get some more in case you need to recrimp some things, or if you want to connect it a different way, feel free to get some different connectors or even solder the wire if you feel comfortable doing that. Those you can find at like an auto parts store as well. You're going to want a 20 amp ATC fuse. Again, one or more of those. You only need one, but if you want more in case you short one out, that's always good to have extras. That can be an auto parts store, along with an ATC fuse holder. You only need one of those. Again, an auto parts store will carry those. You're going to want a 100-watt solar panel. We only used one of these. You can find this on Amazon or any other solar stores out there. Same with some solar panel MC4 connectors. You only need one set of these, and these you can find on Amazon, or again, a solar store will probably carry these as well. You'll want a 20 amp solar charge controller. Only one of these is needed. We got ours from Amazon. You'll want a 150-watt inverter. Only one of those you can find on Amazon or like an auto parts store carries them. You only want to go 150 watts though. If you go a little bit too high, you might short out your charge controller. And then as far as setting the whole thing up goes, which we'll cover in our operation and maintenance video, you want an extension cord to run the power from the electronics module to the fan itself. You'll need as many of those as you need to get, from your panel to the inside of your house, maybe one, maybe two. And those you can find at a hardware store, or if you have any just laying around that you want to use, those will do as well. You want an appliance timer to run the thing, cycle it on and off so you use your power efficiently. Again, we'll cover that in our operation and maintenance video. You only need one of those. You can get that in an Amazon store or like a retailer. And lastly, you want some sort of storage bin or battery box to house your components all in one place. You only need one of those, and again, that's something you can get from Amazon, a retailer, or if you have a bin laying around that you want to use, you can use that as well. First, you're going to want to measure around 2 feet of 14 gauge wire, then cut it and strip it. We can have as much as 3 feet of wire running in either direction here, so 3 feet of wire on the positive end of the battery and another 3 feet of wire on the negative end. But we know that this wire won't have to run for very long. We want to leave ourselves with a bit of a safety buffer. Using wire that's too long could result in the wire overheating, so it's always better to go a bit under. Next, you're going to want to grab your fuse holder and connect it to this piece of wire. The fuse should be as close to the battery as possible, so if your fuse holder is a long end of the wire and a short end of wire, connect the long end of the wire to this wire that you've cut. For our first iteration of the design, we used this fancy wire connector that uses clips and is great for temporary connections. But if you want something a little more secure, you could also use a butt connector. That requires a bit more twisting and crimping, but it will create a more permanent and stable connection. Next, you'll want to grab one of your 20 amp fuses and insert it into the fuse holder. It doesn't matter which way the fuse is facing, but make sure that's in there nice and snug and close the top over it. You may not have to, but we stripped a bit of extra wire in the fuse holder so we could be sure it would be prepared for this next step. Grab your battery and a ring terminal and stick the remaining end of the fuse holder onto it, then crimp it down and make sure the connection is solid. Now you want to wire this up to the positive end of your battery. We did this by sliding the ring onto the bolt and hand tightening the nut over it. If you want this connection to be super solid, you could do this with a wrench or with pliers, but just making sure the connection isn't too tight so you can disconnect it if you need to is important, which is why we just used our hands. Now is a good time to check that our connections are as secure as we think they are. We use the multimeter's resistance settings to check the resistance between the positive terminal and the end of the positive wire, as well as between the negative terminal and the end of the negative wire. Once we know these connections are secure, we can go ahead and grab our charge controller and hook up the battery to it. It is important that we connect the battery to the charge controller first, followed by the panel and the load, to ensure the charge controller isn't damaged. Locate the positive battery terminal on the charge controller and, after unscrewing it, insert the positive wire and screw it down to fasten it. Be careful not to strip the screw, but also make sure this connection is secure by lightly tugging the wire and just adjusting the connection as you need to. You'll do the same thing with the negative battery wire at this point, inserting the wire into the open terminal and fastening it with the screw. If all your connections are secure and if the battery has enough charge, the charge controller should light up at this point, reading off the voltage of the battery. Next, you want to prep the solar panel for connection to the charge controller. We did this with MC4 connectors so that we could have an easy disconnect between the panel and the charge controller. First, you'll measure out, cut, and strip two sections of 2 to 3 feet of wire. For the first wire, you want to locate the male connector, shown here, as well as the female pin, which is the larger of the two types. Insert one end of the wire into the pin and use a crimping tool to crimp this connection. With our crimping tool, this is a bit frustrating, and we recommend slowly working around the outer edges at the bottom until you have a secure connection. You can test this connection's conductivity with your multimeter like we did earlier. Next, you'll remove these two caps from the male connector and slide them over the wire. Insert the wire and make sure the connection is secure, then slide the caps back down into place and twist the large one down to fasten it. For the second wire, you'll go through a similar process with the female connector, shown here, and the male pin, which is the smaller of the two types. You'll crimp down the pin onto the wire, insert it into the connector by sliding the caps over it, inserting the wire into the connector, and then finally replacing the caps, as we did before. To connect these to the panel, simply connect the male wire to the female panel connection and vice versa. The connections of these panels should be labeled as positive and negative. Make sure to keep track of which is which so you can make the correct connections to the charge controller. We'll go ahead and connect the panel to the charge controller now, similarly to how you connected the battery to the charge controller. First, you'll locate the positive solar terminal in the battery and connect the positive wire to it, and do the same with the negatives. If all your connections are secure and if the panel is receiving some amount of light, the panel indicator on the charge controller should light up. Our last connection will be in the inverter. Our inverter came with a cigarette lighter plug that we needed to remove before we could plug into the charge controller. You might be able to just snip the plug off, strip the wire back with a knife, and work with what's inside, but we played it a little bit safer and dismantled the plug to see what was inside. We can't guarantee that cutting the plug off will work, so do that at your own risk. To do this, we located the two screws on either side of the plug and unscrewed them, then grabbed a flathead screwdriver or something similar to pry those pieces apart along the groove running up the plug. You don't have to worry about getting a little bit aggressive here because there's nothing inside the plug that's worth really being careful over. Once you get the thing open, it should look something like this. The red wire with the spring is what carries positive current to the inverter, and the silver strand with the two prongs carries current away from the inverter, making it our negative wire. The tip from the red wire and the prongs from the negative wire can both be cut off with wire cutters. You're going to want to separate these wires from each other a bit so you can insert them into the charge controller. The silver wire wraps around the red wire a bit as they go towards the inverter, but that's okay since the red wire is insulated from it. You'll insert the red wire into the positive load terminal of the charge controller and the silver wire into the negative load terminal. Plugging the inverter wire into the inverter itself should turn the thing on if all your connections are secure. In this picture, you can see that our solar panel isn't connected to the charge controller even though we set it safest to do the panel second and the load last. That's okay too. At night, the panel won't be receiving any power, which is essentially the same thing as it being disconnected, so this is a safe thing to do. At this point, you're almost done. All that's left to do is connect the fan to the inverter with an extension cord. And then in our operation and maintenance video, you can see how to set the whole thing up so it can run in your house.